In this lesson, we're going to look at some different ways that you can classify acids and bases. So the first way is that they can be classified according to the number of hydrogen ions that can dissociate from them. And hydrogen ions are also referred to as protons because that's really all they are. And so that's how these acids have the name with protic in it, because that's referring to the protons. So the monoprotic acids are acids with only a single hydrogen. So an example of that is hydrochloric acid. When it dissociates in water, it produces one hydrogen ion or one proton, so it is monoprotic. An acid that contains two hydrogen ions that can dissociate is called a diprotic acid. So di meaning two, diprotic, two protons. So an example is sulfuric acid, right? So that's H2SO4. So what actually happens are a set of two dissociations. So first, one hydrogen ion dissociates, and so you get the hydrogen ion and then the hydrogen sulfate ion. And then that hydrogen sulfate ion dissociates into another hydrogen ion and a sulfate ion. So when you put those two together, you end up with the overall dissociation of two hydrogen ions and one sulfate ion coming from one molecule of H2SO4. And then if you had to guess, you would probably decide that acid with three protons would be a triprotic acid. And so an example of this is phosphoric acid. And so it goes through three dissociations, right? So one hydrogen dissociates, and then there's an ion left. And then another hydrogen dissociates from that. And then there's the hydrogen phosphate ion with one hydrogen. And so that dissociates. And then we get to just the phosphate ion with no hydrogens. And so overall, the hydrogen phosphate molecule has dissociated into three hydrogen ions and a phosphate. So that was one way that acids can be classified, which is based on the number of hydrogens that they have. Another way is they can be classified as either strong or weak, and both acids and bases are categorized this way. So those are the strong acids: hydrochloric, hydrobromic, hydroiodic, nitric, sulfuric, and perchloric acids. And you don't need to memorize these, but those are the strong acids. So what makes an acid strong? So we've just been talking about the fact that an acid can dissociate in water and it produces hydrogen ions and anions. So a strong acid is one that dissociates completely into ions. So with hydrochloric acid, for example, every single molecule of HCl breaks apart into hydrogen ions and chloride ions. There are no molecules of hydrochloric acid, the HCl, left in that solution. It's all hydrogen ions and chlorine ions. And that's what makes it a strong acid. So there's the dissociation equation. And so what this means is that the concentration of hydrogen ions in the solution of a strong acid is stoichiometrically equal to the concentration of the dissolved acid, so the whole compound. So example, if you have a 2 mole per liter solution of HCl, that means you also would have 2 moles per liter of hydrogen ions. Okay, they're stoichiometrically equal, which means the mole ratio, occurs with the mole ratio, so 1 HCl to 1 hydrogen ion. If you were to have a strong acid like H2SO4 which dissociates into 2 hydrogen ions, then you would take that mole ratio into consideration when you were figuring out the concentrations. Weak acids, on the other hand, are acids that dissociate only slightly in water. And most of the acid molecules remain intact. So what that means is the concentration of hydrogen ions in a solution of a weak acid is always less than the concentration of the dissolved acid. So if we look at an example, acetic acid, which is in vinegar, is dissolved in water. Only about 1% of the acetic acid molecules dissociate in a 0.1 mole per liter solution. So in that solution, there are lots of intact acetic acid molecules and only a few that have actually broken apart into hydrogen ions and acetate ions. So here's the dissociation. You'll notice a different arrow there. So this just means the reaction is reversible. If you continue studying chemistry, you'll learn more about that. So before dissociation, you say you had 100 molecules of acetic acid. After dissociation, you would have 99 molecules, and then you'd have 1 hydrogen ion and 1 acetate ion. So only a small amount actually dissociate. So in this 0.1 mole per liter solution of acetic acid, there's not going to be 0.1 mole per liter of hydrogen ions. There's going to be less than that. Bases can be categorized the same way. Okay, so here's some of the common strong bases. Again, you don't need to memorize those. So sodium hydroxide, potassium hydroxide, calcium hydroxide, strontium hydroxide, barium hydroxide. It's really that hydroxide that makes them strong bases. And so just like a strong acid, a strong base is one that dissociates completely into ions in water. So for example, sodium hydroxide, every single sodium hydroxide compound is going to break apart into sodium ions and hydroxide ions. And so just like with acids, this means that the concentration of hydroxide ions in the solution is stoichiometrically equal to the concentration of the base. So if you had a 1 mole per liter solution of NaOH, you would have 1 mole per liter of hydroxide ions. So weak bases are those that dissociate only slightly in water. Most of the base molecules remain intact. So the concentration of hydroxide ions in a solution of weak base is going to be less than the concentration of the base itself. And so there are a lot of weak bases. One common one is ammonia, NH3, and you'll notice that it's not as recognizable as a base because it doesn't have the OH. And so what happens here is the ammonia reacts with the water and ends up producing hydroxide ions. So the last idea is concentrated and dilute, right? And these are often confused with strong and weak. So the terms strong and weak refer to the extent of dissociation of the particles in water, whereas the terms concentrated and dilute refer to the actual amount of solute in the solvent. So a concentrated solution has a high concentration of solute, whereas a dilute solution has a low concentration of solute. And you can have a concentrated solution of a weak acid, or you can have a dilute solution of a strong base. You can have all the different options. And that's shown in these diagrams, right? So on the left, the strong acids. So you see that the strong part is represented by all of the HAs, which are the acid molecules, have broken apart into H pluses and A minuses. But when it's dilute, there's not very many of them. And when it's concentrated, there's a whole bunch of them. But they're still all separated apart. Then on the right, you have the weak acid, where a lot of the HAs have remained bonded together and only a few have broken apart. That's what makes it weak. But in the dilute solution, there's not very many of the molecules or the ions. And in the concentrated solution, there's more. So that's the difference between strong, weak, and dilute and concentrated. And that would apply to bases also. So those are a few ways that acids and bases can be classified.